Hello, my name is Veli Mustafa Yönder. I am PhD student at İzmir Institute of Technology. I will now start my presentation, which is named Using Artificial Neural Networks and Space Syntax Techniques to Understand Mass Housing Design Parameters. The design of mass housing is a complex process that involves the use of large number of components and parameters. Specifically, novel ways are used to develop and support design stages that transition from conventional to digital creative process. Within this framework, the effect that the designer has throughout this process is rethought and explored in relation to the shifting conditions. Artificial neural nets, space syntax methodologies, predefined rules will help shape the steps of schematic design process and establish certain limitations. The field of mass housing design has been changed by the impact of digitalization, which has resulted in the proliferation of computational design models, data structures, AI approach, and algorithmic way of thinking. Computational learning algorithms, which have a sophisticated framework, make eloquent extrapolations by utilizing forecasting models, learning types, and statistical analysis of enriched data in different dimensions. These approaches can fulfill essential components of reasoning modules and learning types. The effects of these machine learning models are increasing not only in engineering problems, but also on the designer's tasks and design methods. Estimating the parameters and importance percentage that affect the design process can be tested with machine learning approaches. Within the scope of this study, the parameters affecting the mass housing design were tried to be estimated according to the artificial intelligence model and space syntax methodologies. Several academic works have been dedicated to the study of mathematical methods for elucidating design difficulties and formulating methods for resolving them. Computer-aided design technologies have the potential to make a constructive contribution to the states of the design process that include creative problem solving, early design phase, communication, and visualization. According to Oxma, the active involvement of the computer in solving the design problem is different from simply making digital drawings when considering the computational design states. According to Kotnik, computability and its importance for digital design in architecture illustrate that the computer is not a neutral instrument, but actively shapes how designers approach design. The effective use of parametric modeling tools has the opportunity to affect the design states in many ways. According to Kolorevich, parametric design is a digital technique that enables endless variety of shapes and forms, either through drawing the modeling software's embedded geometry or by visual programming tools or scripting. Artificial intelligence approach, unique protocols, digital tools, and hybrid models are all viable options developing novel and innovative concepts in mass housing design. Artificial intelligence and machine learning have advanced significantly over the past couple of decades and now include a wide range of powerful tools. AI approaches include efficient models for solving complex and nonlinear problems. Artificial neural networks, which are components of supervised machine learning approaches that mimic the brain, enable meaningful interpretations and inferences from the processed data. According to Typhoon, ANN is inspired from the information processing of biological nervous systems, such as the brain. Another computational model approach, space syntax, is included in the analysis part of this study. The term space syntax refers to a range of approaches that can be used to represent and analyze various types of spatial layouts. The analysis of spatial configurations has been primary application of the mathematical framework known as the space syntax, which is founded on topology and graph theory. Data collection, defining rules, building an artificial neural network model, variation extraction, and space syntax make up the major components of the methodology utilized in the study. An artificial neural network model was developed with the JustNN tool. All input and output values are aligned between 0 and 1. Depth map X was used to obtain visibility graph analysis. Visibility graphs for both site plans and architectural floor plans were studied. Syntax 2D tool was used to obtain isoist analysis. A graph was used to get node-based graphs and internal distance, mean depth, relative asymmetry, difference factor, and integration values. Space syntax approaches can be used to understand the structure of the houses and evaluate their spatial relationships. Justified graphs, which are tree-like structures, are used as part of the concept of space syntax. The integration of the units of contemporary residential projects of an architectural firm has been studied. Later, it was interpreted with the rule-based approach and many alternatives were developed. Furthermore, isoist analysis, such as occlusion, compactness, and area, was implemented at various points on the sample layers. Due of the sophistication of cell structure, even supercomputers are insufficient. Hence, basic neural models have been constructed. The multi-layer perceptron has been applied to predict future trends, approximate relationships between variables, and classify data into discrete classes. Activation functions, number of neurons, optimization algorithm, learning rate, learning momentum, and epoch number are some of the hyperparameters for training ANN models. Within the scope of this study, the artificial neural network model was developed based on sample projects, gross area, net area, number of rooms, number of bathrooms, whether there is a balcony, whether there is a vista, and preference score. In final neural net, the gross area is not included in the model. The artificial neural network model was developed with a feed-forward and backpropagation learning algorithm. Only 24 instances were used for training, while the remainder were utilized for validation phases. During the training step, the learning cycle was 18,301. The mean error was 0.051%. The target error was 1%. The validation accuracy was 100%. The learning rate was 0.6 and the momentum was 0.8. The relative importance of the input factors is as follows: net area, number of rooms, number of bathrooms, presence of view, and presence of balcony. The first result of this study is the development of concepts that were developed with digital and analog procedures for the initial part design stage. The rules that must be followed during the development process have been established, including the outputs of neural net model, the architectural program, design decisions, space syntax approach, and geometric characteristics. The investigation into appropriate distribution of mass resulted in producing 8 prototypes, 6 of which had solutions in 2 dimensions, while the remaining 2 contained solutions in 3 dimensions. According to the factors affecting the housing design, design alternatives were produced iteratively with parametric CAD and building information modeling tools. Throughout this development process, many parameters such as solid void ratios, output from neural network models, and space syntax methodologies were utilized. During the first stage of the design development, a total of 12 different settlement types and masses were created. According to the ANN model's input relative importance, just 4 of them were chosen, and the development of phases was carried out from that. As a result of this, 4 dissimilar strategies have been investigated to lessen the density of masses. The design decisions for floor plans and site plans incorporate all 4 of the previously mentioned alternative approaches. Simultaneously, visibility graph analysis were obtained. In some blocks, the correlation between the number of rooms and the kind of dwelling stays the same, but in other blocks, it veers off in a different direction. Furthermore, the organic plan schema features blocks that have a geometry that combines multiple surfaces into polygons. The purpose of its multiple surfaces is to broaden the viewing area as well as to facilitate the participation of a great number of people in visual communication. 4 dissimilar design possibilities were generated using technology from parametric computer-aided design approach and building information modeling technology. Since there are several phases of concept design, an attempt was made to improve the solid geometry-based requirements that were generated. The level of details in the design alternatives was carefully maintained. Boolean operations such as subtraction, union, and intersection, and geometric calculations are included in the modification and manipulation steps. Regarding the design of floor plans, the application of space syntax methodologies has proven to be extremely helpful. In addition, when planning the layout of communal spaces, air volume was considered. Furthermore, it is necessary to conduct a three-dimensional analysis due to irregular polygonal geometry, architecture programming, and multi-surface scenarios. This was done because it was essential to determine whether the buildings would have one or two levels. The mass formation benefits from undergoing development stage as well as trials that take place in three dimensions. In discussion section, digitalization has an impact on decision-making and problem-solving strategies for complex situations such as extracting and analyzing design patterns. The importance of creative thinking aided by sketch, rule-based design approaches, artificial intelligence methodologies, and space syntax techniques cannot be overstated in the context of schematic design. The need of producing prototypes iteratively and incorporating input has become a major aspect in tackling complex design problems. This study demonstrates the importance of bridging the neural network model, space syntax methodologies, parametric CAD and BIM tools, and 3D design development procedures for mass housing design protocols. In future research, several learning algorithms will be employed to estimate the design characteristics of mass housing. And thank you for listening.